All right, let's take a look at this collision detection business with rectangles. It's a little trickier than you might think. So I got a little set of pictures here we're going to look at. What we're going to do here, imagine this border here is our canvas, and I've got some numbers in here. The proportion and the scale is totally off. Just ignore that. I mean, clearly this is not a perfect square, but yet I'm calling it a 500 by 500 square. So ignore that. I just put some numbers in there that to help us kind of make a little bit of sense of this. So let's just start here. Imagine that right here in the center is a rectangle, and we're going to call it a perfect square, even though it's not square in my picture, and it's 200 whatever pixels wide and 200 pixels high. So that's this square right here. Now, one thing that's important with this collision detection, we're going to have to remember, number one, the top left corner of our canvas is X position 0, Y position 0. As I move down the canvas, I'm still on the X 0 here, but the Y position is increasing. It's at 250 and then eventually down to 500 if that's how big our canvas is. As I move across the top like so, my X position increases, but my Y position stays at 0, right? 250 is my X, 0 is my Y. 500 is my X, 0 is my Y. So it's important to understand that X gets larger as we move to the right, and Y gets larger as we move down, all right? The other thing I want to point out is when we create in our code a rectangle, we pass in 4 parameters, right? We pass in an X, a Y, a width, and a height. So when this rectangle was built, if this were actually built in our code, we would have passed in an X of 100 and a Y of 150, a height and a width of 200 each. That's what we would have passed into to build our rectangle, right? So this rectangle right here, that's called this, and you'll see why I called it that in a minute, why I called it this in a minute, is starting at position 100, 150. And then it goes still at 100 on the X right here. And then this number is referring to that exact point right where the crosshair is that point of the rectangle. Each of these numbers are referring to that very corner of the rectangle there, okay? So by the time we get to the bottom of the rectangle, we've added 200 pixels because that's how high it is, how tall it is. So it's at position 100 for the X and 350 for the Y. And again, these proportions are wacky, but the numbers, the math still works, right? And the right side here, we have the same idea going on, okay? It grew by 200 in width, that's why it's 200, and then it grew by 200 in height, that's why it's 350. So that's our starting point. Now that we have that as a basic foundation, let's take a look at interacting with another rectangle. So I have here, we've added a second rectangle here. Now these numbers on the edge here are still referring just to the canvas right here. I know it's getting a little crowded right there, but that number, that coordinate is the where we are on the canvas, right? These numbers are still referring to the black rectangle right here. They're the exact same numbers we just saw on this page. It's just now we have another square that's kind of in the way, all right? I'm calling this rectangle other. I'm calling this one this, and we're calling this one other, all right? So here's what we're going to look at here. Ignore this text for just a minute. What we're looking at, if the right side of the other triangle is to the left of the left side of this rectangle. I think I said triangle a minute ago. I meant rectangle. All right, so let me say that again. If the right side of this rectangle is to the left of the left side of this rectangle, then we are not colliding. They are not intersecting each other. So there's not a collision. In other words, if the other's right here, other right, is less than this dot left. So if other dot right is less than this dot left, here's the right. Is it less than this dot left? And it is, because you can see, right, left is at 100, 150. Well, whatever right is at, we don't know exactly, but it's clearly less than that position on the x-axis. It's probably like 90 or 95 or something. This corner right here would be something like 90. So it's to the left of sorry about that. It's to the left of this. So in that case, we do not have an intersection, right? We do not have an intersection when this red text is true. All right, so let's take a look at another scenario. It's the same idea, but now the other rectangle is to the right. So again, the way we're looking at this is if whatever the left coordinate is, the other dot left is greater than the right, the this dot right position, right? So if this left is greater than that right, then we are also not intersecting. And it doesn't matter where this blue rectangle is as far as the y-axis goes, if it's down here, up here, it doesn't matter. As long as this left side is further to the right than this right side is, we are not colliding. So again, other dot left is greater than this dot right, right? Now, there's something we need to consider here. What is the coordinate of the left side of this rectangle here? And by this, I do mean this rectangle right here. With the left side of it, we're looking at the x-axis. It's at 100. What's the right side going to be? Well, you can see I labeled it 300. But the truth is, it's really x plus however big the rectangle is, 200. So it's whatever the x is, because the x of the rectangle will always be the top left corner. In this case, it's 100. So if I add the width of the rectangle, then I now know what the right side is. So you'll see in our code in a minute, we're not going to call these left and right. We're going to call what's labeled as left here in our code is going to just be x, and what's labeled as right here is going to be x plus the width. Okay, and so the same idea is happening over here. The left side of this rectangle is just simply x. So in other words, if others x is greater than this is x plus width, then we do not have an intersection, all right? You may have to rewatch this section because it's a little tricky. So good thing we're recording, right? All right, let's take a look at the next one, the top. Similar situations happening here, right? Here's our this rectangle, same coordinates. These coordinates refer to the black rectangle, all right? Now what I'm looking for is when the bottom of the other rectangle is above the top of this rectangle. And remember, the y-coordinate starts at 0 at the top and it gets larger as we go down. So that means that this bottom number, whatever it is, needs to be less than this top number right here. So the other's bottom, right here, the other's bottom has to be less than this's top. All right? And again, the top for this particular rectangle is whatever its y position is, right? The x and y of every rectangle is always its top left corner. So if I said what's the x value of this rectangle, it would be telling me what this point is right here, this top left corner. In this case, its x is 100, but its y is 150. So the top of this rectangle is just y, or just 150. So is the bottom of this rectangle less than 150? That's the question we're asking. And obviously with the visual, it certainly is. But what exactly is the bottom of the other rectangle? Well, it's the y position of the rectangle plus the height, right? So it's y plus h, the y plus the height. So if the y plus the height, which puts us right here on the very bottom, if that number is less than whatever the y of this rectangle is, then we are not intersecting. So again, there's the equation there, all right? Last one, the bottom. Again, this is the same idea here. Again, the black rectangle is called this, and these are the coordinates for it right here. The other rectangle right here, I'm asking, is the top of the other rectangle, is it larger than the bottom of this rectangle? Right? Well, what's the top of this rectangle? It's simply whatever its y position is. Right? So its y position is going to be something like, 360 or whatever, because this right here on the corner, this black one, is 350. So I'm going to say that's about 360. I don't know. So the top is at 360. Whatever its y position is will be its top. And then we're saying, is that greater than the bottom of this rectangle? Well, what's the bottom of this rectangle? Well, it's its y, 150, plus its height, 200. So a total of 350. So is 360, which is my guess where the top is, greater than 350? If it is, we are not intersecting. So we've just looked at, if any of these four positions, looking at my red highlighted text, if any one of those four positions, other dot right is less than this dot left, or other dot left is greater than this dot right, or other dot bottom is less than this dot top, or other dot top is greater than this dot bottom. If any one of those exists, only one has to exist, then we are not intersecting. So if any of those exist, we're not intersecting. If even one of those, however, if all of them don't exist, then we are intersecting, right? So if this is not true, and this is not true, and this is not true, and that is not true, then we must be intersecting. The moment these rectangles cross each other's paths, none of these red equations will be true, and we will be intersecting. All right, that's a long-winded explanation, but it's tricky stuff, so we got to make sure we understand it. So now let's dive into the code and see how this is all going to play out. All right, here we go. We have our JavaScript right here, and if we look, this is where we left off. We just drew these two rectangles. I'm going to change it up a little bit. What I'm going to do is attach that rectangle to my mouse so that I can drag the rectangle around and bump up against that rectangle and test our collision code, all right? So here we go. First thing I want to do here is I'm going to add a variable to my thingy class. If you remember, the thingy class is what we're using to draw the rectangle. So I'm just going to add a little variable here that's called this dot a, which I'm saying is standing for attached, is equal to a. So we're going to add that parameter here. So now when I create a thingy, or a rectangle in this case, I'm going to pass in a true or a false value. True meaning it's going to be attached to the mouse, and false meaning it's not. So right here where I created the first rectangle, we're going to say it's false. And this one is true. Okay? So now we got these two rectangles. Now, let's down here, I'm going to write this collide function in a minute. We started that in class the other day. In the move function, I'm going to, whenever the move function is called, if this dot A is true, then I'm going to have it move wherever my mouse is, right? Well, we've already created this whole little thing here with where's my mouse event? Right here, the mouse move, all right? And on the mouse move, it just stores the coordinates of the mouse. So we're going to take advantage of that down here, and we're going to just simply say that if this dot A is true, then we want this dot X to equal mouse dot X, and we want this dot Y to equal mouse dot Y. All right, so all that's going to do is set up, anytime we move, this event will fire right here, get coordinates. This event will fire every time we move our mouse. And if we have the tMove function, which is the, let's see here, T is the false one, so we want to actually do the uMove function, okay? We want to show both of them. The uMove is the one that we want to move around with our mouse, so whenever I call the uMove function, look what will happen here. This will call this line of code here, and if it is the attached variable is true, then whatever the X position of the rectangle is, we'll attach it. It will be assigned to wherever my mouse is at that second. Hopefully that makes some sense. And so the other thing to keep in mind here is that this draw function, which is looping over and over again, will continuously call the move function. So this move function down here will be continuously checking to see if attached is true, which it always will be for this particular object. And so every time that move function runs, it will continuously change the X value to equal the mouse. Well, that X value for the mouse is continuously being changed because our mouse is continuously being moved in our event handler. So this event, in other words, this function is being run every time I move my mouse, and this event right here, this move, is being run just constantly over and over again because of our animation loop here. And so the fact that this is always changing and that this function is always moving, the rectangle will move every time I move my mouse. So let's just see if that works. And there we go. Now this rectangle is attached to my mouse, right? And you'll notice, where is my mouse? It's right on the top left corner, which is the X and the Y position. And I said right here, set my X to equal my mouse's X position. Well, remember, the X of a rectangle and the Y of the rectangle is the top left corner. All right, so now in a minute we're going to write some collision code, and I'm going to move my rectangle right up to it, and then the moment it touches, we're going to see if my collision code fires or not, okay? So let's do that. This is our collide function here. Where are we? Right here. Now remember the way that the left and the right and the bottom and the top works. So we're going to make some little notes here, and remember that the top of any given rectangle is just simply equal to its x position, right? And the left of any given rectangle is just equal to its, sorry, I did that backwards. That's the y. All right, and the left is equal to its x position, right? Okay, well, what's the bottom? The bottom is equal to the y plus the height, not the handler event. And then what is the right? It's equal to the x plus the width. Hopefully that makes sense based on that long-winded explanation I gave over here, showing how all this stuff works, right? All right, so again, just a real simple look at this. This is the xy, 100, 150, and I said, what's the top? Well, the top is just 150y. It's just the y coordinate. What's the bottom? Well, it's the y coordinate plus 200 more for the height, which gives me 350, which is why the bottom is y plus height. All right, easy enough. Now let's take a look at this. I'm passing in a function here called other. So what ultimately is going to happen, not a function, but an object, which is just going to be another thingy. So ultimately what's going to happen up here is in my draw loop, I'm going to ask the question basically, if u dot collide, I think, what do we call it? Collide. Let's go with collides. That's a better name. If u collides with t, right? That's the question I'm going to ask. I'm going to say, if this collides, then console.log it, right? That's what we're going to say. So I need this function down here to return true or false. Well, keep in mind what's happening. U is one of the squares. It's the one that happens to be attached to the mouse. And T is the other square. So U is this. What's this? This is always the object that's calling the function, right? So at the moment when I am about to run the collides function, which version of it am I running? Because I've got a T and I've got a U object. Which one am I running? Well, I'm running the U's version. And so that's what this is. This refers to the object that's calling the method. Well, what's this other business here? T. Well, that's the other one, right? So that's why I called it other. So we're calling this this class, this function, we're passing it in this as a parameter, as an argument, to be captured by that parameter. That's the other one, all right? So we want to say something like this. Remember our formulas. We got them all in that spreadsheet over here, right? So I want to know if other.right is less than this.left. Well, let's just copy that right here. Let's see if I can copy it right out of there. And we'll have to modify it a little bit. Okay, if other.right, well, there is no right property, right? What is right? Well, it's x plus y. So if others x, or plus width I meant, plus others width is less than this dot left. Well, what is left? Left is just simply x. So this dot x. So that's one of the conditions right there, all right? And I got a feeling that this is going to get really long, so I'm going to change this variable to just be called O for other, instead of, so that way we have a lot more room. All right, so if this condition is true, or let's look at our next one here, I can just copy and paste it. This one right here is true. So again, we're going to change that to an O. And then what's left? Well, we know left is actually just x. So if others x is greater than this is right. Well, what's right? It's x plus w. So this dot x plus this dot w. Okay? And let's look at the next one. If that's true, or this is true, or this is true, right here, let's copy that one. And again, we're going to change that to O. So what's bottom? So if others bottom, others, that's y plus h. So others y plus others h is less than this is top. Well, what is a top? A top is just y, as we can see right there, okay? All right, so if any of those three are true, or last but not least, if this is true right here, all right? Let's copy that. All right, and we're going to call that other again, just O, I should say. So if O dot top, well, what's top? Because there is no such thing as a top. We didn't create a variable called top. It's y. So we're saying, in other words, y. All right, is greater than this dot bottom. Well, we don't have a bottom, but we do have a y and an h. So y plus this dot h. So if any of those things are true, then we are not colliding, right? So I can return false if any of those are true. Else, return true. That's it. That's the whole algorithm right there. Assuming I didn't screw anything up, which you never know with me, right? All right, so I just saved it. So again, we're going to ask the question, if U is colliding with, and maybe a better name for that would be is colliding instead of collides, but whatever. If U collides with T, then console.log hit. Now, when we first run it, if I did my code correctly, it's going to log a bunch of hits right away, because before I actually move my mouse, the rectangles will be on top of each other. So we'll see that happen, assuming I didn't screw anything up. Let me open up the console here and get this out right here. All right, so now I'm going to refresh the page, and look, it's logging a bunch of hits, right? Because my rectangle's on top. So let's clear that. And so here we go. I'm going to move my rectangle from the right side here, and we'll go right up against the edge there. And so far, nothing. Hopefully right when I get there, almost there, bam, it's a hit. Look at that. Okay, so I got 70 hits. Let me just, now I got 82 because I bumped it there. Let's come right to the bottom here and watch that 82 number go up as soon as I touch right there. Look at that, okay? So let's clear that out. Now I'm going to go reposition this left rectangle here. I'm also going to change the color on it. And so we can, because right now I can't get this rectangle to the left side of it yet, or above it, so I'm going to reposition it. And I want to change the color so we can see it a little bit better. So let's come back over here, and we'll make the one that's starting off, we'll make it like at position 500 here. Let's just see how that looks. Yeah, that's better. We can play around with that. Okay, that's good. That might be too much. Maybe more like 200. Let's try that. That's almost there. Sorry about that, folks. 250. That should be good. Okay, I just want to, yeah, so I can get around it without bumping into it. Okay, there we go. All right, and I want to change the color real quick. So I'm just going to do a little quick thing here with the attached, where I'm drawing this for the fill style. I'm going to actually use the ternary operator right here. So instead of it equaling blue, I'm going to say it's equal to this dot A. In the event that it's this dot A, which is the attached one, then I want it to be blue. Oops, that should be a question mark. Or it should be pink. Right? So let's just, if you don't know about the ternary operator, this is a good chance to look at it. All this is saying here is, based on this truth value, you either print that or you print that, right? So if this is true, then print blue. If this is false, then print pink, right? So this ultimately is going to resolve to either blue or pink, right? So this is, you know, it's not really quite an if statement or a switch statement. It's called the ternary operator, and these are the key things, the question mark and the colon, right? So in the event that whatever I put here is true, then this one is printed. In the event that whatever I put here is false, then this one is printed, okay? All right, so that will change the one square will be pink, one will be blue. All right, so there's the pink one, and here's the blue one. I'm going to clear that again. And let's come up to the top. Whoops, I didn't mean to do that. Up here on the top, so watch, there's no hits. I'm coming down, here we go, closer, and not quite touching yet. There's a little bit of green there, and right there, now it's touching, okay? And it's saying now, look, I've got 86 hits. Let's increase this a little bit so we can see it. Let's just clear that again so we can see it nice and clearly, right? So look how close we get. No hits. Right there, as soon as it touches. All right, so we have 69 hits now when I get, watch it, right when I get to the edge there. Nothing, and as soon as I touch, it starts going. So it looks like my collision detection is working. Obviously, if I'm intersecting it anywhere here, none of the conditions of a false intersection are true, right? So the top of the blue one is not greater than the bottom of the pink one. So that's why we have a hit. If it were, then we would not have a hit, right? It's also true that the left of the blue is not greater than the right of the blue, because if it were, we would not have a hit. You can watch the counter stop when I move it. It's also true that the bottom of the blue one is not less than the top of the pink one. So since that's not true, I'm getting a bunch of hits. As soon as that becomes true, I can't be intersecting anymore. And last but not least, the right side of this blue one is not less than the left side of the pink one, because the moment that becomes true, we have no hits. So that algorithm seems to be working just fine. Let's look. One last thing we can do. This is a nice little trick when you have something that's just going to return a true or false. This whole thing right here will evaluate to just true or just false. So I could just simply say return this, which is almost what I want to do, right? Because I want this, whenever this is happening, I want, whenever that's true, I want to return false, if that makes any sense. So I want to return the opposite of that. So I can just simply say return not that whole thing. Right? Close that out, get rid of this. So if I just say return that and not that, because remember, if this is true or that's true or whatever, that means I'm not intersecting. As long as one of those is true, I'm not intersecting. Okay? So if I'm not intersecting, then I want my hit to be false. So, but if I'm not intersecting, this whole mess becomes true. So I want to return not that, okay? Because I'm not intersecting, right? When this is true, that means I'm not intersecting, which means if I return the opposite of that, it means I'm returning that I'm not intersecting, right? Which is what gives me this value, that if that's true, console out a hit. And that's it. So I'm going to delete the little note here, all right? And so here we are, we have this little teeny collision function. It's just basically one line of code. Let's make sure I didn't break it. And here we go, clear the hits. And nothing, hits all around. When I move hits, I move off, stops. In, out, stop, and go. Looks like it's still working. So that's it for intersection collision detection, as we call it. It's a very important concept in programming, especially when you're programming games. There's one other little tip I want to show you here that can cause an issue if you're not careful. It depends on the application that you're trying to do. But let's give this rectangle brush dot line width is equal to 10. And let's do brush dot stroke. Right, so we want to actually have a line on it. And we want the brush.fill style to be equal to, what's the color that will contrast with pink and blue? Like, let's do orange, I guess. See how that looks. Okay. Oh, not fill style. Sorry. Stroke style. Okay, so there, you got this big, ugly orange. Yeah, that's pretty good. Okay. Maybe I want a different color on my blue triangle or blue rectangle. So we're going to do the same idea right here. Let's just do this. And if it's true, we'll give it a nice red border. And if it's false, we'll give it an orange border. All right. So now, yeah, there we go. That's what we're looking for. Okay, clear that out. Now notice here what's going to happen. Watch when I get close. Notice right now it's not colliding, okay? But a little bit more and now it starts colliding. What's happening there is that the border, it sort of changes your XY a little bit. It's a little wonky what happens. So what I'm going to do to show you what's going on there, I'm going to quickly not make this U here, and I'm going to reattach the text, the mouse text here, so you can see the coordinates, right? And so this particular square here we created was at 250 by 250. Well, look where 250 is. It's kind of like, let me scroll way big here. Okay, it's right there. Notice that it's not at this pink corner and it's not at this corner. It's like sort of halfway in between, right? And my Y is at 251, so if I move my, there we go, perfect. If I don't breathe, I'm holding my mouse right now, you'll see that that is sort of dead center between the actual box and the edge of the border. And the truth is, if we make that color transparent, that orange transparent, watch this. So let's just make that orange RGBA, like red 255, sorry, 255, and the green like, I don't know, 50, and the blue 50, and about 0.5 transparency there. I think I got all that correct. Let's see what happens here. Yeah, you can actually see now, look at the border. That border is transparent, it's translucent, and so what you see is you can see the pink behind the border there. That pink is coming from that box right here. So the corner of the box is still right there. But the border doesn't add, remember I made a line width of 10? It actually does not add 10 pixels to the border. It adds about half that, exactly half that. So that 10 pixel border, 5 of it's inside the box, 5 of it's outside the box. So if you have a border on there, so let's make it a little bit more obvious, like a huge thing here. All right, let's screen that a little bit. And let me get rid of that other rectangle too, that's bugging me. Where's my draw? Just, I think U is the one I need to hide there. Yeah, okay. So I know this is weird because the color I chose, let me get a different color here so it's very, very clear what's going on. We'll make this 0, and we'll make the green 255. Let's see. And now I got a green on green background. Oh, sorry, folks. There we go. Okay, so this is really tricky to see what's really happening here. This blue, because it's translucent, it looks like I've got 3 things going on. Like I got some pink thing, I got some purple thing, and I got some blue thing. The truth is I have a pink thing and a blue thing. That blue thing is really thick. It's from here to here thick, right? It's this thick. That's how thick it is, right? Or this thick. Just so happens that half of that thickness, right, it's oh, let me just get that out of there. The thickness is 50. Well, half of that 50 is the purple, the other half of that 50 is the blue. And the reason you can't, it looks 2 different colors is because the blue is actually see-through. I've made it transparent a little bit translucent. So what you're really seeing is this pink underneath the blue, which is making it look kind of purple. But really, I've just made that blue sort of see-through, right? So that's what's going on. But my point in telling you that is that where is the 250 by 250? It's right there, which is halfway through the border. So if we're going to do collision detection when you have a border, you have to take into consideration the width of the line. All right, so that was my whole point in that. So let's go back to showing everything the way we had it. Getting rid of that. I think that's everything. Let's just see if we're back to where we started here with our collision detection. Yeah, looks like we're okay. All right, so now I'm going to change this to something a little bit more manageable here, back to a 10. What I need to do here in my collision function right here, I need to access this line.width business. So I'm going to set that as a variable so I can access that. I'm just going to say this dot line width equals 10, right? And then down here we're going to say line width is line width, all right? So now what do I have to do to make this work? All of my variables, I have to basically add the width, the half of the thickness of the line width. So line width divided by 2 basically, right? So where do we add that in? Let's take a look at our picture here. I want the collision to happen right here, not right there, which is where it will be happening. So it's happening right here. Well, I need to add 5 more pixels so that it'll get to the edge there. So that is every time, let's see, looking at the X here, I want to add in another plus line width, this dot line width. And do I want to do this? I want to do others dot line width divided by 2. I think that will give me that, and I'm going to have to do that in every spot here. So it's going to be, I might mess this up a little bit. Let me just see if I can think through it here. Stand by while I do that. So also on the X position, I think we're going to need to add that. So let me just copy that little thing right there. I think that's going to be the case. Let's just see how that's playing out real quick. And we get errors, of course. I found the errors right here. I should have said this dot line width. All right, so here we go. Save that and save that. Run it again. And okay, so we're clear. Let me just clear that. Make sure. Yeah. All right. So the errors are gone. Okay. So now let's just see how our interaction is now. If it's any better. Not quite. Let's look at the right side. See how we did there. Okay, I still need to add some more of these adding 5s everywhere. So pretty much everywhere I have an X, it looks like, is I'm probably going to have to add, that should be this dot line width, right? I'm adding the width of whatever square I'm looking at. So in this case, I'm looking at X. I need to actually add in its line width as well, or half of its line width. And in this case, it's just thinking about this is super tricky. Let's see, I should be able to say other dot line width divided by 2, oops, plus. Let me just try to add it to all the X's first, and then plus this dot line width divided by 2. I think that's every spot there. Let's just look. Yeah, I think we got that. So let's see how we're doing now. Okay, so here we go. Still not quite getting it. Oh, I know why. Yeah, okay. So what's going on here is when I'm looking at the left side, which remember the left side is just X, I actually want to subtract, right? Because the X position is right here, like in the middle corner there, right where that purple is. It's hard to show you with my little pointer on my rectangle hanging out here, but right there on that corner where the purple is, that's where X is at the moment, which is, let's say that's 250, I believe, right? Well, I need to actually look at 245, which is 5 pixels before that. Okay, so that should be, when I'm looking at X, I need to subtract that out. When I'm looking at, actually that one's right, when I'm looking at just plain X right here, okay, I need to subtract out the width. When I'm looking at the right side of the triangle, of the square, the right side is, again, it's X plus the width plus 5, or plus half of this, right? When I'm looking at the left side, it's the X position minus half, right? Hopefully that makes some sense. So in other words, let's look at our fun little picture here. Right here, the X position is 100. If I added a border to this, which this is not a border, this is just me labeling stuff, but if I did add a border, well, the border would actually be at 95 instead of 100. It'd be 5 pixels over. 5 of the pixels would be inside of here, and 5 of them would be on the outside of there if I added a 10 pixel thick border. So that's why we need to subtract that out. Okay, that's on the left side, but on the right side, where would the border be? Well, it'd be 305, right? Okay, so on the left side, this is actually the right side right here because we're adding in the width, so that's how we know it's the right side. So we want to also add the thickness of the border, half of it. And then this is the left side, so we want to subtract that 5 pixels. And then here we're looking at just the left side again, which is because X is the left, right? If you remember our notes we had earlier, we had left equals X, and we had right equals X plus width, and we had top equals Y, and we had bottom equals Y plus height. So what's basically happening now, This is without a border. Well, when I'm adding a border, I need to subtract off the line width divided by 2, right? In other words, 5 pixels, because that's where we want to look at our collision. If we're looking at the right side of it, I need to add in 5 pixels. And if we're looking at the top, again, the same idea. I need to subtract out 5 pixels. And on the bottom, I need to add in 5 pixels. Line width divided by 2, like so. All right, so here we go. When I've got this situation here, we're covered. This, I'm looking at x plus the width, which tells me I'm looking at right. I'm also adding in the half there. Okay, so it looks like my x collision detection should be working now. So let's just test that out. Let me shrink down a little bit, refresh the page, clear. So now I should, right when they touch, hopefully, bam, looks like that's working. And the right side here, let's see, perfect. All right, so let's just fix the y here. And again, the same thing. At the moment, when I'm looking at y, just y by itself plus the height, well, y plus height we know is the bottom. So in that case, I'm supposed to also add in the length, the width, thickness divided by 2. So this, sorry, back up, right here, I need to say plus this dot LW plus O dot LW divided by 2, right? Okay, I'm going to try to break this up into multiple lines here. I don't know if this is legal or not. We'll see. Yep, right here. Okay, that way you can see it a little bit better. Okay. All right. I'm pretty sure I'm allowed to do that, but we'll find out in a minute. Okay. Yeah, I think this is fine. Yeah, that looks good. Okay, so let's finish looking at the y's here. So this particular y of the other object, right, the O object, I'm looking at y, which is the top of the this rectangle, plus the height. That means I'm now at the bottom, plus half of the thickness of the line. That means that I'm outside on the edge of the border. If that's less than y, well, what's y? It's just the top. But I need to subtract out those 5 extra pixels there, divided by 2, right? All right, and here we are. We're looking at the top of the y. Well, we need to subtract out those pixels there. And this dot y plus the height, which means the bottom of this rectangle. So I need to add in this dot LW divided by 2. Assuming my little spacing here is legit, we should be good to go here. All right, so it looks like no errors. Let's try the bottom here. Nothing, nothing, nothing. Still nothing. Bummer, we got a bug, apparently. I wonder if it's just because of my spacing, so let's just try to fix that spacing real quick. I wanted you guys to be able to see the code pretty clearly now, but it's getting pretty darn hideous. So that's why I wanted to kind of word wrap it a little bit there. But looks like we're kind of stuck with this. Turn off my word wrap. Yeah. Make it super teeny here just for a second. Make sure all my word wrap's fixed. All right, then we turn the word wrap back on. And let's refresh it. Yeah, it looks like we're working again. Okay, so here we go. Bottom. Yep, right when I touch. Right when I touch. Looks good. Okay, so I think we got it. And just to make sure, let's just make this border like super thick. Not 550. Okay. And clear that out. And it should right there. It looks like it's working. All right, right there. Yep. And I can barely fit it in there, but it is working even though I'm right against the edge. And at the top, same idea. It's working even though I'm barely touching it. So it looks good. So I think we got it. Hopefully all that's a lot of stuff. I know it's a kind of messy business there. So hopefully you now got your head kind of wrapped around collision detection a little bit.